Hi, future doctors. Welcome to the next class. So, we were discussing moment of inertia of ring and disc completed. Now, we will see hollow sphere and solid sphere. So, it will be visible like a ring here, but sphere is going to be different. It will be coming like this, like a rubber ball. So, it will be having only two axes, like ring and disc. It will not be parallel to its plane, perpendicular to its plane. It will be having about diameter. So, about diameter, what is the moment of inertia of this hollow sphere? So, 2 by 3 m r square. Next, about its tangent. About its tangent means this one we came to know, this is I naught, then this is going to become tangent. Moment of inertia about tangent. So I is equal to, these two axes are parallel, I naught plus m r square. What is I naught means? 2 by 3 m r square plus m r square. This is going to be 5 by 3 m r square. This is about tangent. If we are taking solid sphere, so rubber ball is nothing but hollow sphere. Inside nothing will be there. So this is nothing but solid sphere. Again, about diameter. So I is equal to. So for this 2 by 3, 2 plus 5, 2 plus 3. So this is going to be 2 by 5 mr square, about diameter. Now about tangent, if you want to get. So about tangent means, so this axis is I naught, this axis is going to become I. Now about tangent, this is about diameter. This is about diameter of hollow sphere. Now this is about tangent means, again these two axes, I is equal to I naught plus mr square. I naught is 2 by 5 mr square plus mr square. That is going to be 7 by 5 mr square. So they will ask ratios for us. So whenever they are asking ratios, we have to do very carefully. So ratio of moment of inertia of hollow sphere and solid sphere, about their diameters they will ask. About the diameter means, here this is 2 by 3 divided by, here it is going to be 2 by 5. So therefore answer is going to be 2 by 3 into 5 by 2. So 5 by 3. So about tangent if they asked. So 5 by 3 by 7 by 5. Correct? So like that you have to do. Any ratio they may ask, otherwise they will ask radius of gyration ratio. Radius of gyration or gyration. Okay. So for all these, I is equal to m k square is the moment of inertia in terms of radius of gyration. So for ring, about its center, passing through its center perpendicular to its plane, m r square. If you compare with k, so k is going to be equal to r. Next, for ring, about diameter, what we said? About diameter is going to be mr square by 2 for the ring about diameter. At the time, if you compare k square is going to be r square by 2 if you remove m, then k is going to be r by root 2. They may ask radius of gyrations also. Next, about diameter is completed. Next, tangent. Tangent will be having in its plane perpendicular to plane. So whichever equations we are going to get, always you are going to compare with this k square. Now we will see here solid sphere or hollow sphere. Hollow sphere about diameter. What we got here? 2 by 3 m r square. Now what is the radius of gyration for this? You will be getting comparison k square equal to 2 by 3 r square. K is root 2 by 3 r. So very simple, whichever term is coming beside m, For that we have to apply root. This is radius of gyration for hollow sphere about diameter. Now for solid sphere you can say directly means 2 by 5 for solid sphere, root 2 by 5. This is for hollow sphere. Both the axes about diameter. They may ask about tangent. About tangent means what we will do? This equation we will take. 5 by 3 root 7 by 5. So in 1 year they ask what is the ratio of radius of gyration of hollow sphere and solid sphere about diameter. That is going to be root 5 by 3. But in options they didn't give that root. Okay, whoever doing, they will be doing moment of inertia only. But for that we will apply square root. If you apply square root, that is radius of gyration. If you didn't apply square root, that is moment of inertia. Like that logically you people can remember. So all the axes you should remember very carefully. Then only we can solve the problems on this. Now this is the axis. Say the axis name passing through its center perpendicular to its plane for ring mr square. This one is mr square by 2 above diameter. This one is tangent perpendicular to its plane. Tangent parallel to its plane. If it is mr square, this is going to be mr square plus mr square, 2mr square. So it is mr square by 2. And this is going to be mr square by 2 plus mr square, 3 by 2 mr square. Like that you have to remember fastly. You can play like this for ring and disc and for hollow sphere and solid sphere. Then you can remember all this. Next, we'll see moment of inertia of thin rod. So, if it is a thin rod of length L, so what is the moment of inertia about an axis passing through its center perpendicular to its length? If it is only thin rod, it is rotating like this. This is the axis of rotation. So, whenever it is rotating like this, what is the moment of inertia? That is going to be m L square by 12 passing through its center perpendicular to its plane. If same rod is rotated about this axis, passing through one of the end perpendicular to its length. At the time, already we came to know this. This is going to be I naught. What is I naught? M L square by 12. If rod mass or thin rod mass is capital. Now, about this axis you want. Now, what is this length means? L by 2. So, at the time, it is going to become. So, I we want. So, I is equal to I naught plus mr square. These two axes parallel. What is I naught now? M L square by 12 plus M. What is capital R? R is going to be distance between these two axes. L square by 4. So, take LCM. So, 12. So, M L square plus 3 ml square. So, 4 ml square divided by 12. That is nothing but ml square by 3. So, about one end of the rod, if it is rotating like this, if this is the rod, if it is rotating like this, if this is the rod, if it is rotating about this axis like this. So, then what is the moment of inertia of this one means? ml square by 3. Sometimes they will change this axis. So, if it is length and mass of the rod, so they will give this axis at a distance L by 4 from one end. Then what is the moment of inertia about this axis? I they will ask. So we came to know this one, I naught. Now what is the distance between these two? We have to find this. Now this I naught will be at center. So this is going to be L by 2. Then what is this one? L by 2 minus L by 4. So this distance. Then capital R is going to be, so 4 is LCM. So 2 minus 1. So that is going to be L by 4. So half of that. They may give L by 3. They may give L by 6. That is their wish. However, they are going to give. Again, we will do I is equal to I naught plus M R square. What is I naught here? ML square by plus ML square by 16. Sorry. ML square by 16. So again, you have to calculate this. Then you will be getting. So here they may give L by 3. At the time, you have to take L by 2 minus L by 3. That is going to be R. So like that, you can calculate. This is about thin rod. Now, next, rectangular lamina. So length A, breadth B. Otherwise, length B, breadth A. So this rectangular lamina can be rotated in how many ways? How many ways means we'll see. So if this is rectangular lamina, this one can be rotated like this. Whenever you are rotating like this is the axis of rotation. So axis of rotation will be which one? Like this. I, Y along Y axis, moment of inertia. This rectangular lamina can be rotated like this. Whenever you are rotating, this is the axis. This is going to be I, X. This can be rotated like this also. So whenever you are rotating like this, it will be coming. Correct? So whenever you are rotating like this, book you will rotate or plank you will rotate like this. Na? For that axis of rotation will be like this, perpendicular to its plane. This is going to be Iz. If you know Ix and Iy, you can calculate Iz. Which axis theorem? Perpendicular axis theorem. This is the first time and last time we are going to use this perpendicular axis theorem. Now Iz, to get what is Ix, Iy. So Ix means perpendicular to A. See, if you observe perpendicular to A, therefore Ix equal to m A square by 12. We will apply this. Next, Iy is perpendicular to B. That is nothing but m B square by 12. Now Iz is nothing but m A square by 12 plus m B square by 12. So Iz or moment of inertia perpendicular to its plane passing through its center is going to be m by 12 A square plus B square. So we were discussing already the magnetic moment of small bar magnet. So north pole, south pole. So length A, breadth B. But A is less than B we took. So in that we have taken this formula. Why? Because this is like short bar magnet is equal to rectangular lamina. In second year you will use wherever you are getting moment of inertia of short bar magnet, they will use this. But A is less than B, therefore they will take mb square by 12. Here small m is mass of the magnet. So small m here poles you should not get confused there. mb square by 12 you have to remember mass of the magnet. Okay. So by using this we will get hollow cylinder, solid cylinder. If it is hollow cylinder means inside nothing will be there. This axis they will call about its own axis. Another axis they will rotate perpendicular to its length. Radius of this one is going to be r they will take. So about its own axis if it is rotating, how you will be seeing means this is hollow cylinder, inside nothing will be there. Let us assume this is not there. If it is rotating like this, it will be visible for you like a ring. So for ring, this axis is passing through its center perpendicular to its plane. Therefore, this is acting like a ring. This axis is equal to this. Therefore, about its own axis, m r square. For solid sphere, sorry, hollow sphere, moment of inertia about its own axis is mr square because it will be visible like ring. Next, perpendicular to its length about this axis. Moment of inertia about this axis. I is equal to, so this is perpendicular to L. Therefore, we will follow this formula. M A square by 12, M B square by 12. Here, M L square by 12 plus this, whenever it is rotating, here it is like a ring. For ring, this axis is which axis? Diameter. About diameter for the ring. What we said to remember like this. So this is mr square by 2. Mr square means this is going to be mr square by 2. Therefore, you will be getting here mr square by 2. So this is the moment of inertia of hollow sphere passing through center perpendicular to its length. About its own axis means like a ring, therefore mr square. Next, this is for hollow cylinder. Now for solid cylinder. Solid cylinder, what you will get means same equation. You people only can say. Now this axis can be about one axis. How it will be visible? It is like disc. For the disc, what is the axis name for this? passing through its center perpendicular to its plane. About its own axis, I is equal to m r square by 2. It is like ring, therefore m r square. It is like this, therefore m r square by 2. Now next axis, passing through its center perpendicular to its length. Then I is equal to m L square by 12. So passing through its center perpendicular to its length. In addition to this, here what will be visible? Like this. For disc about diameter, half of that mr square by 2. That is going to be mr square by 4. Like that logical you have to remember. So this is like a ring diameter mr square by 2. This is like disc diameter about diameter mr square by 4. These are the moment of inertia according to our NCERT textbook. So therefore, I am giving only moment of inertia is related to NCERT textbook only. Still so many will be there. I am not giving all those because we are following only NCERT based formulas and concepts. Thank you.